This is recording of my technical interview on a position lead full stack software engineer in a company developing web-based API services and JavaScript client-side applications. Let's see how it goes. So my name is Andriy. I bet it's some kind hard to pronounce for not Slavic people, so please be free to adapt it to Spanish or to English. I am Ukrainian. Talking about programming languages in the industry, I am like about 20 or some years. I started in early in end of time in the previous interview, I guess. Sometimes I feel like too old to say my experience, but my milestone of a start of a career basically was born of the C# and .NET technologies platform. So I am with a very first version of the .NET, with a version 1.0. And with that, I'm basically do all my backends on .NET and C# as language. Together with C# and .NET, I adapted some JavaScript just because what I prefer to develop is web services, web API, and everything is connected with the web. And talking about web, I started with the C# web forms, the very first implementation of the C#. And since that, it became clear that not knowing JavaScript is not an option at all. So basically, JavaScript is like a satellite where I'm trying to be as much advanced as I am in a C#. And talking about JavaScript, I also learn and know some kind of Node.js, web APIs, and all the things where JavaScript is running on a backend, not only in web browsers, and trying to keep my knowledge in both directions, like a front-end and backend. But I obviously been asked what do I prefer, backend or front end? And here, to be honest, I prefer backend just because I'm very bad at the layout and design things. I have no idea how to place a couple divs around the browser without any kind of documentation for any kind of advanced layout grid system. So I am not a design person at all. Talking about positions I attained, obviously for 20 years it was like a lot of them, but let's say I was absolutely everywhere on all positions, starting from a developer and ending like a C or CTO technical positions, including leads, tech leads, team leads, project managers, and all the things. And in the end, right now I work as a full stack software engineer. I do coding, I prefer coding, but with that, managing people and communication with people around the code is another one thing what I think I do really nice, just because I've been doing this for a lot of years already. That's it about me. I think it's some kind of connected with experience, because people who have started from their database design, from their high load distribution on a system, they somehow cannot understand why it's important to have a button, let's say blue. Why? If the system sucks, if it doesn't work, who cares about color of a button? But there are people who really believe that making color blue will solve all the problems, including performance ones. Conflict with a coworker, maybe it's kind of not a rude but very strong term, from my opinion, to describe relationships between coworkers. Conflicts, basically, they should not exist in a company where everybody serves the same purpose. Anyway, if two people or two coworkers have a conflict, it's already something unhealthy inside the environment of the company. If it happens, and if there is a conflict, and to be honest, I cannot say that I didn't have any conflicts, but probably I have some kind of a tension between
That works.
Yeah, basically what I usually do, what I learned to do, I put aside all my individual needs or individual beliefs and things, put aside. Let's pretend that I was like in a conflict, I am in a conflict. I'm trying to, first of all, to understand, is it a conflict related to a personality or is it a conflict related to a job? If it's a conflict related to personality, that's not an option. I'm not going to solve it. It should not exist. We're all professionals and all people should be like, don't discuss any kind of personalities. If it was conflict related to a job, there are some roots of a conflict. Someone has done something wrong. Someone should perform some actions in order to solve a conflict. That's it. We serve a company. We do not serve our own egoistic. For example, when I was young, I was pretty eager to be always right, but that time already gone. And talking about recent conflicts, maybe the latest one when we, for example, let's say work on some project, let's say frontend and backend together, and I know, and the person knows, and everybody in team know that one of us doing more job than the other. For example, I'm doing API, I do tests, I do some kind of state management on the client side, and front-end guy, he doesn't perform as much as I am. Basically, in other cases, it could be a conflict. I could say that, come on, I'm working more than you. But in my specific case, when we just came together with our manager and we described amount of job done by each person in order to find a root cause of the problem. And in my case, it was absolutely not a personal, absolutely not a work related. It was just because my coworker, he didn't perform enough from my point of view, just because he had some kind of own personal problems and it was not connected with the job, personality and everything. We just took a pause, we solved, he actually solved his own problems. Then we get together in order to split our obligations in a project once again, who is doing what, who is responsible for each part, and what is more important, who is blocking in the process. And we just remove the blockers and that's it. So I cannot imagine, to be honest, let's say, I cannot imagine myself to have a conflict with a coworker. I don't see any reason. Maybe I'm too old in order to solve too much conflicts, or I'm too naive and I'm lucky to work with the people who also don't fight for the like. I would like to add that escalation actually works, because when you escalate a problem, then the solving of a problem is done. People who are not involved into the problem, they don't have personal feelings about solving a problem. They like, they also don't care. They need to solve a project needs. If it, so maybe maybe it's important to escalate on time. Escalate not when it's too late. And it's also not a shame to say that you cannot do anything. You need help from other people. Yes, with IT. Or...
Yes, not related with your work.
Okay. Okay. It will not be related to my work, but we have. I'm new in language, in the Spanish language, and I always had jokes that Spanish and Spain people, they have a term which means I will do something later, nobody knows when, like mañana.
Mañana.
Yeah. So I always will make any jokes that Spanish people, they're not lazy. They just tell you they will do something mañana. It means when, nobody knows. And something what I learned, that actually all the time I was wrong, because there are two words, mañana and la mañana. something means tomorrow,
Okay.
something means in the morning. So I feel guilty to make these stupid jokes about mañana and about Spain people just because I was stupid enough to mix these two terms, didn't know that they are absolutely different. So that's what I learned.
Yeah. Yeah.
To be honest, all my production backends always been hosted on Azure. And
Okay.
with that, yeah, sorry. With
No,
that,
it's just to know if you have worked with it
yeah, yes, I
or
do.
not. I suppose that if you have been working with C# and .NET, and
Yeah, because
you
of
should deploy it somewhere, and you should have the knowledge in order to do it. So
yeah. So
AWS.
just having everything on Azure makes me pretty bad in the AWS and Google Clouds. So
Okay.
to be honest, for AWS, I did couple research projects connected with hosting Kubernetes cluster on AWS, just to find out how it works there. But
Okay.
none of production experience of mine connected with AWS or Google Cloud, so only Azure.
Right.
I think AWS hosts more. I mean, this is
Yes.
the biggest cloud. And to be honest, I think they adopted some services earlier or before all
Yes.
others. So maybe they are the one who invented a lot of things.
Yeah.
I prefer Azure just because with Azure I quickly can do much more
Yeah.
things that than
Yeah, for sure. If you are working in .NET and C#,
yeah,
it's not many reasons to use AWS.
yeah. Probably they are not really different. They are just add. I mean, it's a two different things made for two different purposes. Docker is a way to abstract operating system.
Hmm.
So it's not a cloud. It's not anything. As I remember, Docker were born in the Linux world, made from, I believe, three technologies like virtualization of a file system, virtualization like a execution of the namespace, and some other things. This is the way to present operating system like something virtual and execute some code in isolation. Guys from a Linux kernel made it possible with their, I believe, C coding skills and magic they do with the Linux kernel. And when it became possible to virtualize piece of hardware by the operating system itself, it became possible to compose and to aggregate and to join different Docker, let's say, pieces. I'm not talking about images, containers, or pods, actually how they call it Kubernetes, but two different things of a Kubernetes into one single piece of load or piece of software. In Kubernetes, it's called pods. It's basically your own operating system plus a monitoring container instance of your system, and then connection between all monitoring system into a single control plane, which is then responsible for like creating and keeping at the expected state of your system or of your composition. So there are two different technologies, they just work together perfectly. A little bit, but not on a production level. It means that I did some kind of investigation and we basically decided to not adopt Terraform at the production level. The purpose of the investigation was if it's possible to make cloud agnostic deployment of our compositions. And we, of course, found out some kind of cloud agnostic things like Pulumi or Terraform or some other things where it's possible to describe state of your system, like how many app services, instances, what kind of load balancers, what kind of databases and volumes you have, and describe it in a way where we can deploy composition to any cloud. And obviously it became pretty clear that there is no such thing as a common or same for all cloud infrastructure, because in Terraform, with the Azure provider and Terraform for AWS provider, there are two different Terraform types, or Terraform, I don't say languages because language is a YAML for everybody, but two different set of configuration parameters, and it's not possible to take like Azure Terraform and deploy to the AWS.
No.
But the beauty of a Terraform is that you have all your infrastructure in a not single, but in a same way of simple text files, where it's possible to version control, to deploy as many times as needed, to do some kind of short-term deployments in order to do, for example, performance tests, or to test some kind of theory against your project, and then destroy, don't pay for any constantly started resources in the cloud, and basically to be able to reproduce production environment in your local cluster in order to understand how does it work in the cloud, but in your local environment. So Terraform is amazing piece of software, and I think I a little bit regret that we did not adopt this type of cloud deployment in our production project. Yeah, for production, we still use Azure App Insights for all our application tracing and logging and problem solving. Unfortunately, we don't use application insights as a single single tracing and log storing mechanism. Like, for example, in a Grafana, where we have a couple services and everything is aggregated in a single place. Unfortunately, we don't have that. Instead, we have individual app insights for each our application services. What we're trying to do, we're trying to find a place where logs are more likely to appear. For example, if we have an application gateway, then we do definitely trace and log all API calls in the application gateway level in order to understand the performance of a system. So what we do on production is app insights only. It's hard. Just because if we start learning microservices, we will see that everything is beautiful, everything is distributed, everything is easily reconfigurable and easily. It's a simple solution, for example, to have a complex system working under the load or something else. So microservices seems to solve all the problems, unless we actually started implementing microservices. Because for me, microservices is not the silver bullet which solves everything, especially when you're starting to lose some kind of messages between services in the communication level. That's a hell to find out what's wrong. For example, if we imagine two APIs or two job services talking together with some kind of in a async way with, for example, even bus or RabbitMQ, and something is not right with the microservices, is a hell to find out the problem. And as soon as we already talked about logging, so it's a hell to find problem without good logging solution. For us, in our own microservices implementation theory, we stopped at a level where we have simple web APIs responsible for different things. These APIs talk together by two communication strategies. First one is a request response, which makes our microservices solution into something what's called distributed monolith. And the other in the other communication way with a async way to postpone execution of the services by putting some messages into some database or into a queue. And for Azure, we use Azure Event Hub for that, in order to make this like postponed execution in case when we don't need request and response behavioral pattern of our microservices. So answering the question, do we do microservices? No, we don't. We met a situation where it's hard to maintain our solution if it were only microservices based. What we do is a distributed monolith plus some asynchronous invocations in order to have pub sub mechanism. So that's what I know about microservices, and that's how we adapted it. This technology is amazing itself, especially with the Kubernetes, especially with the virtualization of applications with the service buses, with the databases. It's amazing, but its biggest challenge is to find where microservices is needed, what kind of problem they solve, and adapt microservices correctly. Otherwise, it become a hell. Basically, security inside the microservices is some kind of topic which is, from my point of view, a little bit more complicated than it appears. For example, when we take like any kind of API, let's say we have like an API to get list of products. Obviously, it should be secured with TSL, and all the hosting should be behind the HTTPS. But then the question is, when we're starting to do a microservices, who is responsible for all the certificates? Is it a same API service responsible for renewing, for example, HTTPS certificate when it's expired or when it's rotated by the plan? So I will say that let's imagine that it's good idea to have single responsibilities or separated concerns about APIs and the SSL, but it means that all HTTP communication for a microservices behind some wall done without SSL. And this is something what is already sounds scary, that we have HTTP services without SSL deployed. But from my point, it's okay for some cases. For example, for the Kubernetes cluster. Inside the Kubernetes cluster, when we don't have a public access to our individual pods and we have only single ingress with a single entrance point, it's okay to have a HTTP communication inside the cluster itself. I don't know, I don't have opinion if it's good or bad, but let's imagine that when we talk about an API, the API should always could be hosted with HTTPS, and someone, I don't know who is responsible to keeping this AS certificate up to date and valid. Then when we're talking about some kind of security at the application level, like, for example, authentication, I can imagine that authentication is an application level concern when we say someone is responsible to execute an API call and get the data. Then, for example, authentication could be presented as this bearer inside the header, a JOT token, and JOT token itself is a little string which represents that this API call is legit for someone for some period of time with some role and with a list of claims, for example, in order to get a response. So this is like an application level of security of the APIs. It's become absolutely different when we talk about messaging solutions. For example, with the messaging, we don't place our bearer tokens inside the message itself. It's because we actually don't know when the message is going to be processed. Let's say we have some kind of delay, or our process service is like down and we are going to process all accumulated messages tomorrow, and tomorrow is the point of time where tokens expired. So why we need a tokens when we don't know when they're going to be used? For that, we use some kind of client key secret type of authentication. Basically, it's a magic string somewhere in the message, usually also in the header, saying that yes, this message placed by some system, and please proceed this message and do something with it. It's not auth, it's not about users, it's about the system itself, and basically single key as a secret solves the problem. REST is from my point of view, is a younger brother of the HTTP. Just because HTTP itself was invented, I don't know when, like previous century or something like that. There are a couple of verbs and couple of ways to talk with a server, like give me something or here you are something. So that's a web, that's HTTP, and it was invented basically to serve static files plus work with a data sent for a processing to the HTTP server. When it become that it's not enough to have HTTP and we need more strict rules behind the communication with a web, for example, for the API or web API services, people starting to talk about REST. And REST as a term been invented in the beginning of the 2000, I believe, in some kind of thesis of some guy in some university, where he decided to make a strict rules about talking with HTTP services, like get request, give me something, and if you need a list of something, you have specific rules to describe that you need a list of data. If you need to get single item, please provide the ID of an item or some kind of identifiable information of an item into the get request URI. If you need to put something or replace or delete something, there are also strict rules about how to ask web server with a REST protocol, like a logic protocol about behavior. For example, replace an item in a system. When we're talking about put, we definitely know that with the put we provide ID of an item we're going to replace, data, and all the data will be replaced with the provided ones. If we provided empty string or we forget something in the put, it will be replaced with its default value. For other things, we have like a communication or verbs like a patch, when we need to partially update, when we have an options where we're able to provide some kind of data above, like to ask, for example, a headers. Talking about REST, I believe there are about 20 different HTTP verbs, and unfortunately we use like no more than 5 or 7. Yeah, if I summarize REST, then it's a communication language between someone who is doing a service and someone who is consuming service. I believe there are like a client or front-end people, and we're talking about REST. A lot of things become obvious about communication. That's good about REST things. Class, it's like a description of a thing, if I can say it like in a normal language or normal people language. So class could have some kind of different access levels, which is decided by the person who is inventing a class. Usually, and in most cases, people use public, where the class is available for everybody. But together with public, there is a way for developer to say that class should be used, for example, inside an assembly, where the class is declared for that we use internal, or private, when we don't want to expose ability to create an instance of a class, or for example to have a method available outside. With that we can use a public. And of course, if when we're talking about inheritance, which is a good thing about object-oriented programming, we have a special class modifier for methods to allow people to consume the method only in the inherited, like a protected one, access modifier to be available. This method will be available in classes which are inherited from the ones. So basically there are, I believe, 4 of them, plus there are some kind of like public, internal, some kind of combination of their like but I'm not really use all of them, to be honest. Definitely public, definitely private when I would like to encapsulate something in it, and of course protected when we use some kind of inheritance chain. That's it. Partial classes is a thing which were invented from my point of view when there are 2 different people started to write a class. Not the people, sorry. For example, when 2 different sources of a class. Let's say when a human writes a class, everything is inside the class itself. But when class, let's say, generated from some kind of external source, from kind of an assembly, or from kind of explanation of the class, like from YAML file or from a WSDL file. So when the class is generated, it's a good thing to also allow developer to extend the generated class without modification of the generated source code, just because source code of a generated class could be regenerated. And in order to avoid this, class usually split into a couple things. The part of a class which is always generated and it's safe to generate, and part of a class developed by or written by a developer, by a person. And for that there is special word in a class, like a partial, means that this is just part of a class and other part of a class somewhere else. Basically what was partial for. It's a way to stop inheritance of. So I'm as a developer would like to say explicitly that please do not inherit from my class. I am an author of a class. I know better. You should not inherit anything from that. And for this type of behavior, I can use another one special word called sealed, which forbids inheritance. And I also heard an opinion that by design, if we don't explicitly allow inheritance in a C sharp, in any kind of object-oriented programming, all classes by default should be sealed, and only if I allowed inheritance, I should explicitly say that. But unfortunately, that's not how it is. And yeah, I don't know if it's good or bad. And yeah, so sealed is when I would like to be specific about usage. And to be honest, I don't remember when I last time placed sealed in my class. I'm sorry, but I develop like a web services and web applications, and maybe this is not a big deal. But for people who, for example, develop some kind of class libraries or some kind of assemblies for next usages into some kind of products, they probably use sealed more than I am at the like REST side. But yeah, sealed exists, and we probably may use it when it's needed, but I don't remember using it myself. This is, I'm sorry, but this is another one thing which is beautifully describes all the needs of the behavior of a class, which I never used finalizer in my code. I know there is a tilde, I know there is possible to write some kind of behavior when the engine drops or deletes my class, not myself, not me, not when I outside of a scope, when there is a garbage collector came and say, that's it, I'm going to kill you. This is the last place when you can insert your code. This is finalizer. I will probably execute this code before garbage collection your item. But once again, never wrote anything in a finalize. I'm sorry for that.
Yes,
But come on, if a
it's correct.
developer or if you're smart enough to analyze a heap of your service in order to find out if it leaks or not, then you're probably smart enough to write all your code inside of dispose if it's needed there. So yes, there is a way to implement iDisposable, the recommended way from Microsoft, with a couple override of the dispose. When we check if we're disposing right now, then we postpone disposition. There is a technique to write proper to implement iDisposable interface properly. But the last time I really used this is on a job interview. Never wrote anything where I need to clear resources myself. Maybe it's also connected with the type of software I develop, but nothing connected with disposition in the controllers or in the business classes or somewhere else. But when we screwed up, we still have Kubernetes who will kill our pods when something is wrong. I don't know if it's good or bad, but yeah. There are other things to solve problems with the memory leakages. Only when we inherit from the interfaces. It supports multiple inheritance of the interfaces, but it does not support multiple inheritance from a classes. But if we compare, for example, with its mother language like C, where it actually supports multiple inheritance, and it still don't know if it's good or bad that we don't support multiple inherit, because the problem itself already solved, and we know how to inherit classes in a pretty close language like C. Why it's more than 20 years where C# is used and there is no need to multiple classes inheritance? I don't know, but maybe let's keep it as it is right now. Sorry, I think the element, when we talk about an element in React, we're talking about a DOM or HTML element. But a component in React is already some kind of higher level representation of a UI, of set of elements, described in something like a function, which is basically all components are. They are functions with some state and with some behavior abstracted from the DOM and from the things which are visible in a browser. So I think that's the difference.
Okay.
State is some kind of data which is related to a component, and which is more important, the data is persisted between the component method render execution. So I imagine state of a React component like a separated storage, always available and accessible from inside the component code itself.
Okay.
Props is a way to expose some kind of things needed for our component from the outside. In React, we use some kind of a composition of a components where one component creates a lot of or some other components, and the way to pass data to its child component, there are a couple ways, and props is just one of them. Other ways like a context, or other ways like some kind of Redux way of storage, but props, this is the simplest and the easiest, like where we describe an interface of our component, without which our component probably won't work. Absolutely yes, just because React itself could produce its output not in the HTML. There are a couple renderers, if I can remember correctly its name. This is the outcoming, where the outcoming result of React presented, and I even can remember the name. It's like Eevee or Eva or something like that, where React code basically are functions, because all React code is a simple JavaScript functions. They look like HTML, but it's not. It's HTMX, it's a functions with the ugly signatures and everything. It's just simplified to be not scare people who is going to design something because they're already familiar with HTML. But that function output is possible to present in absolutely any like consumption routine different from a web browser.